Okay, today we're going to do 7.3 similar triangles. So remember, back last semester we did congruent triangles and we had SAS, SSS, ASA, and AAS, and those were ways to prove triangles congruent. We're going to do the same type thing today, but it's going to be ways to prove a triangle similar. And remember, what we have to have triangles similar are congruent angles and proportionate sides. So the first way we're going to prove triangles similar is by AA here. And this is when you're not used to, we didn't have this with congruent, but if we know two angles are congruent, so that's all we need is to know two congruent angles exist, then we know the triangles are similar. There's a lot of different ways you can look for to show that angles are congruent. You can have the same measure, and so it might be marked with, arches being congruent. It might tell you they're both 30. You could have transversal with parallel lines, and you look for those with the alternating interior, alternating exterior, and corresponding. Any of those are options. Vertical angles, so that little bow tie shape we see a lot, that'll have your congruent angle. And then don't forget the reflexive property, which is kind of like this, where there's two triangles inside of each other. And this is on both of the triangles, and so it's reflexive is the same. So it's the same on both of them, so it's congruent. Example 1, we're going to use the AA similarity postulate, so we need two congruent angles. And it says determine whether the triangles are similar. If so, write a similarity statement. Remember, that's going to have your similar symbol in it. Explain your reasoning, and then state which postulate, which hopefully the goal is to use AA. So we only need two congruent angles. And here you can see right away that B and D are congruent, so that gives me one set. But I need 58 is not congruent to 80. Remember though, if you have two angles, you can always find the third. So you're going to add these up to 180, or add them up and subtract them from 180. I looked at this triangle right here, ABC, and found out that the missing angle is going to have to be 80 degrees. Well, now that I know A is 80 degrees, I know A is congruent to E. I have two sets of angles that are congruent. That's enough for me to prove these congruent by AA. That's my postulate answer. And then it also asks for a similarity statement. So if I say ABC, A corresponds with E, B corresponds with D, and C corresponds with F. And there's your similarity statement. Okay, we're going to do the same type thing on 1B. We're still using AA, so we only need two angles. The first thing I see when I look at this is I see my bow tie shape. So I know that angle QXP is congruent to MXN by vertical angles. And then I see my parallel line. So I have one set of angles. That's good, but I'm going to need two. So I look again and I see my parallel lines, and I'm going to look for some angles. You have a couple different options here, but I'm going to take this transversal, and I see this angle P and this angle M. And so those are going to be congruent. And if you kind of turn your head sideways, you can see your parallel lines cut by the transversal, that those are alternating interior. So for my second angle, I'm going to say angle P is congruent to angle M. You could have also said Q and N for the exact same reasons, and that's going to be alternating interior. Like we said, I have two angles, so that's enough for me to prove these two triangles are similar by AA. I'm going to write a similarity statement. Q lines up with N, X lines up with X, and P lines up with M. Great. Okay, I want you to pause the video, work these two, check your progress, and then start the video back and check yourself. Okay, so hopefully you've worked 1A and 1B, and the answer to A is B. Yes, it works. Here's your statement by AA because you can figure out the two measures. 1B is also yes by AA. You have vertical angles and you have a couple sets of alternating interior, and you can check your similarity statement there. So that's our first way is AA. Our second way is going to be SSS, which we're used to, but with congruent, the three sides had to be congruent. Now we're doing similar triangles, so the three sides have to be proportional. So you need all three sets of corresponding sides to be proportional, which we'll be able to tell because our three scale factors will be the same. And then we're going to have our third way, which is SAS, which again, we use a congruent, but there the sides had to be congruent. In this case, we have proportional sides, only two of them, but we have to have the included angle, the one in between touching both sides, that is congruent. Okay, so this is determine whether they're similar and write a similarity statement, and we're going to explain our reasoning. Now, there's a lot of numbers going on here, and the easiest thing here is to put longest with longest, shortest with shortest, and the middle with the middle, okay? Because it's kind of hard to tell, okay, well, does 4 go over 6, or does 4 actually go over 7.5? Maybe it's twisted, but they have to go in order. So if you'll find your smallest, which here is 6, sorry, I started with smallest, and then smallest, and I'm going to go ahead and do biggest and biggest, and then what I'm left with is my medium and medium. That is the way you will check. And so if you do that, now we can check, and you can either reduce it in your head or with your calculator, and they reduce to 3/2. I have 3 sets of proportional sides, and that's what I needed for SSS. So I can prove this by SSS, and it said to write a congruent statement. Now, this is not the only way you could have done this. You recognize your bow tie shape and know that there's vertical angles here, so you could have also done it by SAS. That would work as well. Either one of those answers is perfectly fine. Okay. Again, you're going to do smaller with smaller, bigger with bigger. Here I don't have a medium one, but you got to make sure and use the whole part of your triangle. So what I'm going to do here is I'm going to redraw my little triangles. So there's my top one right here. And then I don't have this trapezoid, I have my whole triangle. So when I redraw the whole triangle, RMS, I'm going to have to add these up to get this whole side. So this whole side is 30, and this whole side is 25. So now that'll help me compare better. We don't want to use this 15 and 18 separately because that's not the side of the triangle. And before I move any farther, now that I've drawn these separately, I have an N here and an N here, and you might have noticed that you're supposed to look out for that included angle right there. So we do know that angle M is congruent to angle M because it's included in both of them, which makes it the same on both of them. So it's your reflexive property of congruence. And so there I have an A. And now let's talk about our sides. So I'm going to take 10, and 10 is the smaller. So I'm going to put it over the smaller. Don't count on it always being on the same side. Sometimes it might alternate. So you've really got to look for that smaller with smaller, bigger with bigger. And that just makes sense. So that's okay. And then 12 with 30. So I have 10 over 25 and 12 over 30. And if you use your calculator, both of those reduce to 2 over 5. So I have the same scale factor. My scale factor is 2 over 5. So I have an angle and then 2 sets of sides, right? One here with the same scale factor. And I can check, that was one side, that was the other. My angle is included. It's touching both of those sides. So it is in fact SAS. And we're going to write another similarity statement. And remember, your similarity statements don't have to be the same. They just have to be in the same order. Okay, so pause this, do the check your progresses on your own, and then start it back so you can check. Okay, so 2A and 2B both are yes. Here I put small over small, big over big. Remember, you're always going one on one triangle to one on the other. One on one triangle to one on the other. Scale factor of 1/3. I have my vertical angles, so I have SAS. Here I have my reflexive angle, and then I got to put small over big, which is going to be the whole, small over big, which is the whole, and I got a scale factor of 2/3, so yes by SAS, and then you can check your similarity statements. If triangle RST and XYZ are two triangles such that, and it gives you your scale factor, Which of the following would be sufficient to prove that the triangles are similar? Okay, so we gotta look. Would it be enough to know two sides are proportional? Nope. Would it be enough to know three sides are proportional? Yes, that could be SSS. We need to check and make sure they line up. Would it be enough to know one angle? No, you have to know two. Would it be enough to know that two sides are proportionate? Only if you had a congruent angle. So that's not enough information. Let's check and see. This could be SSS. Let's see if it's in the right order. So I have RS and XY, that's right. I have RT, and XZ, that's in the right order. And then ST, and YZ, that's in the right order. So here's your answer. Okay, same thing we've dealt with. Reflexive, same on both sides. Symmetric, if you swap it. Transitive, if you take two, and then remember A and B, B and C, then A and C. Okay, so we have two triangles, and it gives us some numbers and tells us these are parallel. And we want to find RQ and QT. Well, first we want to prove that the triangles are similar. And we can look at this and we see our bow tie. So we know that angle QQT is congruent to angle SQT. Sorry, SQR, because it's vertical. So right there I have a set of angles. And then if you look at your parallel lines, again, in your transversal here, you know that these are congruent by alternating interior. So that gives us my second A. So the triangles are similar by AA, which means the sides are proportional. So now that I know they are similar, I can set up a proportion with the sides so that I can solve the problem it wants me to solve. And it's kind of hard to tell what goes with what. Sometimes now here it's pretty obvious the 4 goes with the 10. You can always write your congruence statement and use that to help you line up the rest. So we know 4 goes with 10 and x plus 3 goes over 2x plus 10. Of course, you could have flip-flopped that. That would be totally fine. And I'm going to distribute at the same time. And solve. And I get x is 5. And it asks for, always got to check and see my answer, so that's a good start. But it asks for RQ, which is x plus 3, which is going to be 8. And then it asks for QT, which is 2x plus 10, which is going to be 10 plus 10, which is going to be 20. And so those are the actual two answers at once, 8 and 20. But check and make sure it's proportional. So if this were 8 and if this were 20, does it work out with the 4 and 10? Yes, you can check both of those reduced to 10 over 4. So that's a good check method. Okay, I want you to pause where this check your progress and then start it back. Okay, so I worked it out. They're similar by AA because our vertical angles and alternating interior wrote a similarity statement which I could use, set up my proportion, cross multiply, distributed, solve for x, and that's on there. So if you got A, careful, it says to find AC, so then I plugged back in and got 14. Okay, I'm going to stop here and then make another video just to finish out these last couple things.